All right, guys. How you going, Jimmy? Missed you in class today, buddy. All right, let's do this. 10-4. Shh, come on, guys. 10-4, ellipses. As you can see, I have a nice little picture of a celestial body there on space, and that is an ellipse, guys. An ellipse is kind of like a circle, but it's wider or narrower depending on its major or minor axes, which is what we're going to talk about. Most celestial bodies are elliptical, or they travel in an elliptical orbit around another planet, for example, or another star, like we go around the sun in an elliptical pattern. The moon travels around the earth in an elliptical pattern. So ellipses are pretty cool and very useful, especially for space travel and things of that nature. An ellipse is, again, another conic section. We've already seen that there are 4 conic sections. Circles, we got that already. Parabolas, we got that already. And now we have ellipses, okay? And an ellipse is a conic section which is a collection of points in a plane where the sum of the distances from 2 fixed points called the foci are constant. Let's talk about that. The sum of the distances from 2 fixed points called the foci are constant. So what does that mean? Okay, let's just go over all of this and then I'll explain the definition. First of all, when you have an ellipse, it could be like this, okay, where it's longer on the x-axis and shorter in width on the y-axis, or you can literally turn it all upside down like this, and then you'll have it longer on the y-axis than on the x-axis. And I'll show you more in detail later how that goes, but I wanted you to know that you can have 2. You can have one that's longer on the x-axis, or you can have one that's longer on the y-axis, okay? We're going to talk about both, but this is just a general form. I just want to show you what's going on. The longer of the 2 widths, in this case it's in blue, my friends, that is called the major axis, okay? And the length of the major axis is basically 2 times A, which is the distance from the center to one endpoint, that's A, and the distance from the center to the other endpoint, that's A as well, okay? That's the major axis. The minor axis is the smaller of the 2, the smaller width. So that would be this red part here. That's the minor axis, okay? And the minor axis is going to be the length. The length of the minor axis is the absolute value of 2b. Okay, so the distance from the center to the co-vertex is b. Center to the co-vertex is b. Now, when you have the vertices on the major axis, those are called the vertexes, or the vertices rather. That's the vertex. The vertex on the minor axis is called the co-vertex. The co-vertex. Your focus. Focus has been very important so far, especially in the parabola, not so much on the circle. But the focus is so important for the parabola and the hyperbola and for the ellipse, because that focus is what helps define what kind of a conic shape you have. We had said that in a parabola, okay, the distance from the focus to any point on the parabola is equal to the distance from that point on the parabola to the directrix. In this particular case, gentlemen, we're saying that the distance from any point on the ellipse to focus 1 plus the distance from that same point to focus 2 is constant. So for example, if I said to you that this green distance, which is the distance from this point to the focus, let's just say it was 2, just for giggles, then this would be 2. No, it doesn't have to be equal. Let's say that's 2, and let's say that was 5, let's just say, okay? That sum is 7. That means that if I go from here to here, this distance plus that distance, it would be 7 as well. If I went from here to focus 1 and I added the distance to focus 2, that would be 7 as well. If I went from this point to this focus and to that focus, the distance of those two added together would be 7 as well. Does that make sense, gentlemen? Yeah. Okay. So that's the definition of an ellipse. Okay? And you have your foci, -C and C. Okay? That's basically what we're dealing with when we're dealing with an ellipse. It's actually quite simple. These formulas here, the A0, -A0, that's when the center is 0, 0. I'm going to show you the real standard form, though, right now, when you have center HK. HK could be 0, 0, or it could be 1, 5. It could be anything at once. So, excuse me, standard form of ellipses. All right, guys, please pay attention here. The standard form of an ellipse is x minus h squared over a squared plus y minus k squared over b squared. A is greater than b, so pay attention. When the denominator is larger under the x squared value, you have a major axis that is parallel to the x-axis. I'll repeat that. When the larger value is under the x squared section, your major axis is parallel to the x-axis. You with me? If your major axis is parallel to the x-axis, your minor axis will be parallel to the y-axis. That's what's in red, okay? The minor axis is in red, gentlemen, and the major axis is in blue. Is everyone with me so far? So when I have a larger value under the x squared, the major axis is is parallel to the x-axis. You cool? Okay. Now, how do you find c squared? Well, c squared in an ellipse is a squared minus b squared. So we're going to have to use our Pythagorean properties and square root properties to go ahead and solve that. Your foci, okay, which, of course, all of this is labeled here, guys. My foci is h plus c comma k and h minus c comma k. Your vertices, h plus a comma k, h minus a comma k. And your covertices, h comma k plus b and h comma k minus b. Let me give you some patterns that hopefully I'll help you notice. Do you guys remember that in the parabola, when the h of the focus and the h of the vertex were the same, that was an x squared? And remember how when the k of the vertex and the k of the focus were the same, that was a y squared? Well, here, guys, it's a little reversed. Not a little, it's reversed. When the k of the foci is the same as the k of the vertex, you have an x squared. It is reversed. When the k's are the same in an ellipse, you have your major axis is the x-axis. When your k's are the same in an ellipse's foci and vertex, your major axis is the x-axis. When the k's are the same in your foci and your vertices, your major axis is going to be x. You with me? Okay. Trust me, this looks crazy. It's not that bad, I promise. You'll see when we do examples. Now let's check it out, guys. When I have the major axis being on the y-axis. Check it out. Now you have x minus h squared over b squared plus y minus k squared over a squared. A is still greater than b. So when the denominator is larger under the y squared value, you have a major axis that is on or parallel to the y-axis. You guys with me? You sure? Okay. C squared still equals A squared minus B squared. No biggie. The foci, the vertices, and the covertices, everything switches now. The foci now is H comma K plus C and H comma K minus C. The vertices, H comma K plus A and H comma K minus A. The covertices, H plus B comma K and H minus B comma K. Notice the pattern. When the H's of the foci and the vertex are the same, I have a major axis that is on the y-axis. When the H's of the vertex and the foci are the same, I have a major axis that is a y-axis. Is everyone with me so far? Okay, now, let's put it together. I guarantee you're going to breathe a sigh of relief. You're going to go like this. Oh, wow. Okay, we were scared, Mr. Morrow. Trust me. Okay, you trust me? Okay, you guys, some of you trust me, some of you don't. Okay, let's see. Let's see if I'm right or wrong. First of all, my brothers, which guy has the larger denominator? So the major axis is going to be, in this case, it's going to be parallel to the x-axis, right? So we know it's going to be an x-axis. In this case, it will be an x-axis because the center is 0, 0, right? So you know that the center, the HK here, is 0, 0, right? Because there's nothing being added to the x or to the y, right? So just go ahead and label that, guys. H equals 0, K equals 0. Life is a lot easier with these things when you label. So then my minor axis has to be the y-axis. Is everyone with me so far? Okay. If 25 is a squared, what's the value of a, my friends? Okay, 5. Bear with me. If b squared is 9, what's the value of b? 3. Okay. Ready? Ready to really be happy? What's the center? Okay. Isn't my major axis on the x-axis or parallel to it? Okay, so from the center, I'm going to go 5 to the right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 to the left. Guess what? Those are my vertices. 5, 0, negative 5, 0. You loving me yet? Okay. B. B is 3. That's my minor axis. So I'm going to go from the center, up 1, 2, 3, down 1, 2, 3. You with me so far? Okay. C. What does C equal? Well, we know that C squared equals A squared minus B squared. So that equals 16. Square root of 16 is 4. Right? So my foci is on the major axis. So it's going to be H, comma 0, and negative 4, comma 0. Yes, sir? What are the covertices? Covertices are my blue, the B. No, I'm sorry. The covertices here are 0, 3, and 0, negative 3. Did you see, guys, that I didn't have to really make a single calculation except for the C? That's my ellipse. Horrible ellipse, but that's my ellipse. You didn't have to make many calculations, did you? I'm going to try to make sure that you learn how to do this without having to make a lot of calculations. Does that make sense so far? Everyone see what I did there? And you notice I didn't do any calculations, right? I first graphed everything, then I plotted this point. I graphed it, then I plotted this point. The only calculations I did was for C. You with me? Okay. Let us continue. Okay, in this case, my brothers, who is the A squared? Is it 4 or is it 16? Yes, so the major axis this time is going to be the y-axis. Good. The minor axis is going to be the x-axis. Great. What is my center, my friends? What is my HK? 0, 0. Okay, 0, 0. Very good, gentlemen. Okay, what is my A here, gentlemen? Be careful. This is B squared. This is A squared. That's the number one mistake. I'm glad you made it now. Okay? A squared is always the larger denominator. Always. We talked about that. If the larger denominator is over the x squared, then the x-axis or parallel to the x-axis is the major axis. If the larger number is under the y squared, then the y-axis or something parallel to the y-axis is the major axis. You with me, my brothers? Okay. So A in this case equals 4, guys. So go to my center, 0, 0. Okay. And this time it's 4, right? But am I going to go on the x-axis or on the y-axis here? Y-axis, because it's a major axis, the y-axis. So I go up 4, 1, 2, 3, 4. Down 1, 2, 3, 4. Guess what? That's my major axis. So my vertices are 0, 4, comma, 0, negative 4. Instead of having to calculate, I just follow directions. My B, what is my B value, gentlemen? 2, that's exactly right. So to the right I'm going to go 2, and to the left I'm going to go 2 from the center, leaving me with the co-vertices of 2, 0 and negative 2, 0. Does that make sense, gentlemen? Okay, my C. Well, C squared equals A squared minus B squared. So that means that's 12. The square root of 12 is 4 times 3, so 2 square root of 3 plus or minus. So my foci, since my foci is on my vertices, it's going to be 0, 2 radical 3 and 0, negative 2 radical 3. Am I going to be a super stickler on the exact accuracy of where you plot your foci? No. An average is about good. Isn't the square root of 3 a little less than 2, guys? So 2 times square root of 3 is going to be a little less than 4, right? So put it a little less than 4. You feel me? Okay, so there, and put it here. That's your foci, which isn't even really important when you're graphing it. It's just important for when you're proving the ellipse. And there you go. That's your ellipse. Is it bad? It's not bad, right, guys? I told you the parabola is a lot tougher. It's doable, but it's a lot tougher. May I continue, my brothers? Okay, now let's do some calculations. But don't stress. This is easy. Look, check it out. First of all, find the equation of the ellipse whose center is the origin with the focus of negative 2, 0 and the vertex of negative 5, 0. So first of all, if my origin is the origin is the center, my HK is going to be 0, 0. Okay. What do you guys notice about the focus and the vertex? Okay, the y's equals 0, right? So when the k's are the same in the vertex and the foci, it's an x major axis. Great. Great. And the minor axis then would be y. Fantastic, gentlemen. Fantastic. Now, my vertex is negative 5, correct? So before you get all crazy into formulas and stuff, check it out, guys. If negative 5, 0 is one of my vertices and 0, 0 is my center, let's put my center. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 5. So my A is 5, right? Does that make sense? So my vertices, I just wrote them down. 5, 0 and negative 5, 0. I would not have known that if I did not realize that my k's were the same. When my k's are the same, it's an x-axis or parallel to x-axis. Does that make sense so far, my brothers? Yes, sir. Because they told me that my vertex is negative 5, 0, and my center is 0, 0. So my axis goes from my center. So from my center, if negative 5, 0 is a vertex, that means I went 5 to the left. So that means I have to go 5 to the right. Thank you, sir. Okay, next, my co-vertex. Okay, let's see what my co-vertex is. Before I get my co-vertex, no, I was not given enough for my co-vertex. I was given something for my focus. My focus is negative 2, correct? What is my C then? No, guys, come on. If my focus is negative 2, my focus is negative 2. It's right here. Is there going to be 2 on both sides of the center? So my focus, my C is 2, guys. They gave it to you already. They're giving it to you. They're giving it to you. Look at the formula for your foci. Look at the formula for the foci. Guys, go back in your papers. Look at the formula for your foci. No, that's for c squared. Look at your foci when you have a major axis of x. It's h plus c comma k and h minus c comma k. Your k is 0, right? Isn't negative 2 h plus c or h minus c? Okay, what is your h? So what is your c? Has to be 2. Well, plus, remember, the c is the actual distance. The points are 2, 0, and negative 2, 0. So no, the c cannot be negative 2. Thank you for asking, sir. And now, how do I get my b in this case? Well, c squared, which is 4, equals a squared, which is 25, minus b squared. So negative b squared equals negative 21. Divide by a negative, b squared equals 21. Take the square root of both sides, b equals square root of 21. So my covertices are going to be 0, square root of 21, and 0, negative square root of 21. Square root of 21 is just a little bit less than 5, right? Right, guys? So just go a little bit less than 5. 1, 2, 3, 4, 5. So about there. 1, 2, 3, 4, 5, about there. Those are my covertices. And that is my ellipse. Talk to me, boys. Yes, sir. How did I get the 4? Because it's c squared. C squared equals a squared minus b squared. C is 2. C squared is 4. A is 5. Read the labels, guys. So a squared is 25 minus b squared, which is what I'm looking for, gentlemen. Thank you. Good question. Does that make sense so far? Okay. Next. Oh, no. Wrong. Next is below. Okay. Our favorite. Yay, well, we have to complete the square. Okay. Now this time when we're completing the square, guys, remember we want this equation to equal 1 at the end, okay? So first things first, collect my x's together. X squared minus 4x. Collect the y's together. 16y squared plus 32y. Send any constants to the other side. Does that make sense so far? Please write that down. I want you to go step by step. Make sure you got this. Step 2. Let's factor out the 16 from the y, guys. So I got x squared minus 4x plus 16 y squared plus 2y. Because, you know, we cannot complete the square if you have a coefficient in front of the y or the x. Equals negative 4. Okay? You with me so far? Complete the square. X squared minus 4x plus negative 2 squared plus 16 times y squared plus 2y plus 1 squared equals negative 4. Pay attention. Plus my negative 2 squared. Because remember, I have to add the b over 2 squared to both sides. Now here's the trick. Here's the killer. Plus the b squared, right, times what I factored out here. Remember? You got to factor out that a. You got to multiply it to the b squared that you add. Remember that, guys? If you don't, this is a good time to remember that. So it's going to be plus the negative 2 squared, which is for this guy, plus 1 squared times the 16 that you factored out. Huge, huge, huge. Pay attention. Make sure you got that. Does that make sense? Yeah. Guys, promise? Okay. So now it's Mickey Mouse time. Let's do it in red. X minus 2 squared. Done. Plus 16. Y plus 1. Done. Equals Negative 4 plus 4 is 0 plus 16. We got 16. We're almost there. Yes, sir. I'm going to get rid of... What? No, this 16 stays here. Of course. Since you took it out here, you had to multiply it here to balance it out. But that doesn't mean that you got rid of this. No, that stays. Until right now, this second. Is it supposed to equal 16? Okay. So, what do you think? Divide both sides by 16. So this is going to be x minus 2 squared over 16 plus y plus 1 over 1, because 16 divided by 16 is 1, equals 1. That's my answer, my brothers. Yes, squared. That's my ellipse. Little bit of a process, but not that hard, really. Not that hard at all. Okay, what I'm going to do to give me some space. You guys got this, right? Okay. I'm going to do this for a second. Let me take this away for a second. And then let me go like this to give us some space. Okay. Now, this is the equation that I'm working with, okay? We'll put this right over there. Okay? You guys with me so far? All right, now let's do this out the good way, easy. First of all, what's my vertex? What's my HK? Okay, my K is 2, comma, negative 1. That's going to really help me. That's my HK, guys. It's going to really help me. Label, 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 label. Okay, my A squared is under what? The X or the Y? So my major axis is going to be parallel to the X. It's not the X-axis here. It's only the X-axis when the origin is 0, 0. Remember that. But it's going to be parallel to X. So you know it's going to be wider than taller. So my minor axis will be parallel to the Y. Okay. What is my A value here, gentlemen? Okay. Now, the vertices formula is where you're going to really be happy with me. The vertices formula, when my major axis is over the X, is h plus a comma k, h minus a comma k. Why don't we not use the formula and let's use logic? Isn't the center, my brothers, 2, negative 1? Isn't the major axis parallel to the X? Don't I know my A? So just go 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left, and write those points down, guys. So my vertices is negative 2, negative 1, and 1, 2, 3, 4, 5, 6, negative 1. Tell me that's not a lot easier. And you know you did it right? Bless you, son, because the K's are the same there. Is everyone with me on what I did there and how I did that? Now, the B. What's the value of the B, my brothers? 1. So from the center, go up 1, down 1. So what are my co-vertices? 2, 0, and 2, negative 2. You guys with me? Promise? Okay, so now the C. C squared equals A squared minus B squared, which equals 15. So C equals the square root of 15. This is the only one you have to use the formula for. Okay? And the formula for this guy is, I believe, H plus K. No, H comma. No. This is a major axis. So it's H comma K plus B. No, man, that's the vertex. Duh. I was right the first time. H plus C, comma K, and H minus C, comma K. I went from giving you guys 3 different formulas to only having to use 1 formula. It's not bad, right? It's not bad at all. So my H here is 2. My C is square root of 15. So it's at 2, comma, 2 plus square root of 15 comma k, which is negative 1, and 2 minus square root of 15, comma k, which is negative 1. That makes sense? Are you sure, guys? And we know that those are going to be real close to the vertices. And we know that the square root of 15 is just under 4, right? Just under 4. So what's 2 plus just under 4? Just under 6. So 1, 2, 3, 4, 5. It's about there. And then on the other side, just about under 6. So you got over here 2 minus. What's 2 minus just under 4? Just a little bit. It'd be 2 minus like 1 point something. Guys, it'd be less than negative 2, right? So I'm going to go over here, and that's my ellipse. Does that make sense? Talk to me, guys. Awesome. Easier than the parabolas? Okay. Next. Now let's put it all together. I want to graph this sucker. Okay, what's my HK? 3, negative 1. Awesome. Is my major axis going to be parallel to the x or parallel to the y? Parallel to the x. Heck yeah. My minor axis is going to be parallel to the... Okay. Let's go ahead and plot my center. 3, negative 1. What's my A value? 5. Since my major axis is over the x, I go 5 to the right. 1, 2, 3, 4, 5. 5 to the left. 1, 2, 3, 4, 5. Is everyone with me here, guys? So my vertices, write down what you just graphed. Negative 2, negative 1. And 1, 2, 3, 4, 5, 6, 7, 8, negative 1. Is everyone with me, my brothers? Okay, what's my value of my B? Okay, B is 4. So from the vertex, from the center rather, go up 1, 2, 3, 4. Down 1, 2, 3, 4. So my co-vertices are 3, 3, and 3, negative 1, 2, 3, 4, 5. Does that make sense? Okay, now, of course, Mr. Moore is a bit of a stickler. He wants to C. So C squared equals A squared minus B squared, which equals 9. So C equals 3. Okay, there's only that one formula really you have to memorize here, guys. This is a major axis of the x, so the foci is h plus c comma k, good job, and h minus c comma k. So h is 3, c is 3, so 6 comma negative 1, because k is negative 1. And then 3 minus 3 would be 0 comma negative 1. So 1, 2, 3, 4, 5, 6, 1, and 0, negative 1, and there is my horribly ugly ellipse, but perfect points. Does that make sense, my brothers? Promise? Awesome. We're going to practice some right now. God bless you. Thank you for a good lesson.